Alrighty, it's 1:30, so let's go ahead and get started. Hi, everybody. Thanks for coming. Good to see you. Happy Tuesday. Just a reminder, homework 2 is due Friday. If you haven't started it, you really need to. If you haven't met with your group, you really need to. So take a few minutes, maybe after class is done, to just connect with your group mate if they're here and get going on that because it's due fairly soon. The other announcement, so I sent an announcement on Canvas. I don't have office hours on Friday. I had office hours yesterday. So my office hours tomorrow, 3 to 5. Stop by. On Friday, I'm traveling. So if you need help last minute with the homework, you can send me an email. But as I'm traveling, the reply may come later. Yeah, so just a reminder of where we're at. So this week we're looking at sorting. This material will be on the final. So by Thursday, I'm hoping to have a study guide out for you for the final exam. As a reminder, the final exam is in person. It is, so it's in person, handwritten, so no computers. And yeah, so, whoa, what is that? In person, handwritten, that's pretty much it. It's designed to test your knowledge of what's going on in Java and data structures and algorithms. So that's the purpose. And so to do that, you may have to write some code, doesn't need to be syntax perfect, but mostly testing your knowledge. Yeah, so that's kind of where we are. As you came in, I handed back your worksheets from last time. If you didn't get it, let me know. I also have new worksheets for today. So yeah, so our plan is we're gonna watch a video and then we're going to that kind of motivates what sorting is. And then we're gonna go through different sorting algorithms and we're gonna do one at a time where we're going to watch a video on it that I think explains it really well. And then oh no, did I forget them? Please tell me I didn't forget them. I didn't forget them. I have playing cards. And so I'm gonna distribute them. And so for each algorithm, I have the pseudocode for you here on the handout, and it's also in the video. And so your job is to do pseudocode or like simulate it with the cards. And then the third step is, as best you can, you're going to write Java code for it. So there's 3 steps to this. And I'll put you in pairs too. A note for the recording when I post this, I'm going to stop recording when we watch the videos, just because that's not my intellectual property. And so I'll be sure to link the videos on the Canvas page so that like you can pause the video and then go there when we get to that point. Okay, any questions? Okay, so we're gonna do as much as we can today. We may not get through all of the algorithms. So next time we'll finish whatever we don't get today, and we'll have lab 9, which I think should be fairly short. So if we spill over today, then that's okay. Okay, I don't think I opened this before, so let me get this up. Okay, so just to remind you where we've been. So on Thursday, we talked about algorithm analysis, and we were talking about how some things are faster than others. Some things are more efficient in code than other things. And so we talked about here's the way that we can represent this. We do that with the steps of an algorithm. So we choose, here's the main operation that we care about, and we ask how many times does that operation happen? And so these are the common ones that you'll see, where O of log n and O of 1 are the best ones. And so those are the ones we want to shoot for. And then O of n is okay. O of n log n is a little bit worse. N squared and more than that are inadvisable. Just because as your input grows, the time taken to do that also grows. We talked about some examples. We talked about logs. Then we did the worksheet. Okay, so now that we know how to measure some efficiency, we're going to look at some common algorithms. Here, hold on. Okay, so we're going to look at some common algorithms, and some of the best known algorithms that will help us to start with are sorting algorithms. So we'll watch a video. Open hyperlink. And I will pause recording. Okay, so we want to know we want to know how to swap two things. So if we have an array that looks like this, let's say this is thing I and this is thing J. The question is, how do we, so if the thing in this is 5, the thing this is 4, how do we swap that? Yeah.
Think that it's an array also have the number assigned to it. So the first number is 0, 7.
Yeah, so I is the index. So we want to swap the thing at index I with the thing at index J. Yeah. Save I's data to maybe X. Yeah, so let's say this is called A. So like A at I is Y, and then A at J is X. Yeah, that's the basic idea. So I just wanted to go over this beforehand with you guys so that you understand, like, what does swap mean? Because like if I've got two cards, I know how to swap them. I can just pick one up, pick up the other one, put the other one down, put the first one down. But thinking about how we do it in code is one of the next steps. Okay, so this is basically the pseudocode for how we would swap. So today involves a bit of pseudocode and a bit of actual code, to the best of your ability. So to start off, I would like you to, there it is. Okay, where do I want to put this? Let's make a new folder. New package called sorting, and then have sorting.java. Just so this can be where like all of our algorithms for today go. Okay, and so let's say let's take a minute and like try and actually implement the like public swap. Let's maybe assume that all of our arrays are going to be integers. And so if you do what we just talked about and then just return A at the end of it. Okay, so in your groups, I'll pull up the pseudocode again and just implement swap. So if I move this over here. Okay, so work in your groups and implement swap. Go for it. All right, so how do we swap this? Okay, so yeah, so like following our pseudocode, right? So we've got A at Y and we save it to X. We've got A at J and we save it to Y. And then we do the actual replacement. So A at I is now Y. A at J is now X. Yeah. You can do it just with one. How do you do it just with one? So if we set it for this one, we delete. And then AJ equals X. So yeah, so over here, so we've got, got X over here. Let's say this is J, this is I, 5 and 4 to start with. So X is equal to A at I, so that's 5. And then A at I, we replace it with the thing at A of J. So that's not 5 anymore. Now it's 4. But we've saved 5 over here, so we haven't lost it. We still have that value. And then over here, we replace A of J with the thing that we stored. So we don't need 2 temp variables, just one works. Okay. All right, so we're going to go over 5 common sorting algorithms, some of which were covered in the video. Yeah, so as we go, we're gonna watch the video, you're gonna simulate it with cards, and then you're gonna write as much as you can of the code. And then after we're done, I'll post the solution code. Okay. Okay, so first with your suite of cards, simulate bubble sort. So first your job is to find out which one of these is bubble sort on the worksheet, and then simulate it with the cards. If you need more cards, I'll come around and pass some more out. And then code it. All right, so let's come back. So I have the solution that I've written up. So since some of these algorithms gets pretty hairy, I'm gonna give you the chance to write it first. Then I have the solution, and then I'll post this after class for you to compare or supplement what you have. So yeah, so for bubble sort, let me actually put this over here. So bubble sort's got 2 for loops, so nested for loops. where we go from 1 until n, and then the nested one is where we go from 0 to n minus 1. And for each thing, we ask, is this in the right order? If it's not, then we swap them. And so for this version, I just have the swap bit in here. I don't have a separate method. So that's up to you if you want to call the method or to just, because swap is simple enough, so you can just stick it right in here. Okay. Forgot to resume screen sharing. Oh no. It'll be fine. It'll be fine. I'll post this afterwards. Okay, any questions on bubble sort? Okay. Let's move on. I'll give you a few more seconds. I'm going to post this after class too, so don't worry about getting everything copied down. All right. Let's move on to the next one. All right, so let's go back. All right, so I'll show you the solution that I have, which is very much based on the pseudocode. It's like basically exactly the same. And that's the nice thing about pseudocode, where I can give you, this is what the algorithm looks like, and then you can implement it in whatever language you so choose. If you go on and take 374, this is how I'm going to structure that. Yeah, analysis of algorithms. That's how I am teaching that next semester. So I'm going to have pseudocode, and then for whatever you implement, you can do that in whatever language you want. So yeah, so the idea is, this is one of the ones where the pseudocode kind of feels, and the code kind of feels more complicated than it actually is. So that's why I like having the deck of cards to like actually work through it to see, here's what is happening. Because you've got like I and J, which just help you to keep track of where you are in the array. But once you do it with the cards, you see, oh yeah, now I'm swapping these, now I'm swapping these, until the thing is in the correct spot. So just remember that for insertion sort, we're keeping track of what's currently sorted. And we don't go beyond that until we make sure that the stuff that we have so far is correctly sorted. Okay, I'll give you 30 seconds to copy this down if you want. And again, it'll be available afterwards. Alrighty. Okay, let's move on to selection sort. Okay, so yeah, so cards, then implement it. Yeah, one of the things that sorting kind of reveals to us is like, if you've got a deck of cards, like, here's how I would sort this. And it's pretty easy for us to like look at this list of numbers to see, oh, that's the smallest one easily. But remember, we have to be procedural about this, because when we're coding, we can't see all the way ahead. So we have to look through and see, is there anything smaller after this? Okay, go for it. So let's look at the code for selection sort, which should mirror, which one is it? Yeah, question? Oh, wait, maybe not. Okay. All right, so let's move on to, so from here, we've got the more tricky ones. So far, these have been pretty straightforward. Do you agree? Where we go through and we just swap things that are out of order in different ways. But this is where it starts to get, like, these are slightly more complex algorithms. So there are merge sort and quick sort. And so we'll look at merge sort first.
Today, we're going to learn merge sort.
Oh, wait, hold on. Okay. So merge sort has two components. So we've got the recursive bit and then the merging bit, where the merge sort recursive version is just splitting it into different, that's splitting it down into the individual parts. And then the merging is actually doing the merging is actually putting them back together in sorted areas. So these two while loops, no, sorry, it's the first while loop. So the first while loop is saying while A and B are non-empty, so the way this is implemented can vary. You can actually remove something from the array, or you can just use indices and then increment them as you go. So it doesn't always have to be A0 and B0. You do like AI or in index J for B. And so you can go through it that way. But yeah, so you're always comparing which one is smaller, and then you add the smaller one to the array. And so the merging is when the sorting actually happens. Yeah, so this one is n log n. And we've got the log because we're splitting it in half every time. But we're still going through the whole numbers. So this bit is why it's n times log n. Okay, so yeah, so first do it in cards. This one I really recommend. Make sure you understand how it works in cards, and then try and implement it from the pseudocode. And so this might be the last one that we do today. We'll end at about 3, and then we'll discuss. All right, let's come back. All right, so I can't fit all of merge sort on one panel. So, but merge sort comes in 2 parts, right? And so one of the questions that you guys have is, how do we actually do this step of array 1 equals A0 to AN over 2? That's something that in pseudocode we can be like, you can just figure that out. But when we actually write code, we have to say, how am I actually going to make this array that has objects from index 0 to index n over 2? And so the way that we do that here is with for loops. If you're doing it in Python, you could use like the slice operator, and that makes it easy. But with Java, we have to do for loops and do this somewhat manually. So that's one of the things I want to mention. Otherwise, it's pretty much aligned with the pseudocode. let's look at how these translate. So for the first while loop, we have, the way we say A and B both have elements is we've got our new array C, and we've got, whoa, why? I don't know. And we've got two indices that keep track of where we are in A and B. So in this case, we don't actually remove it from B. If you have that, then that's fine. But here we don't actually remove it. We just, whenever we find it, we increment it and then compare with indices. So yeah, so we ask if the thing in A is bigger than the thing in B. If so, the thing in B is smaller, so we add that to C. And as we do so, we use that handy plus plus operator to give the thing, remember, it works, this operator works left to right. So first we add the thing at BI, and then we add 1 to that index. So we add 1 to the variable after getting it. And we also use CI++. So it would be equivalent to say this at CI and then do CI++ and BI++. If we didn't do that in here, that would be the same thing. But just having that makes it shorter. So it's equivalent. And then same here. So for here, this is the case where A has the thing that's smaller. So we add that. So we do this until one of them is empty. And so once one of them's empty, then since we know the subarray is sorted, we're going to just take everything left in the non-empty one and just add them one at a time to C. And so once we add them to C, then we're good to go. All right, so that's merge sort. So we kind of ran out of time. So next time we'll do quick sort. I want to make sure that we have enough time to get to that. So for the active learning today, I want to spend the rest of the time. I'm going to make a new file. You can do that with Control N or Command N. And I want you to answer 3 questions. So 1 and 2 are the easy ones of one thing your group learned. The second is 1 question your group has. And the third thing is, once you just write that down, I want you to do a little experiment of, I was talking to the group in the back about this. Take the set of cards and ask yourself, how do you, like, if we forget all about the algorithms that we learned today, how do you sort it? Like, if you can maybe, because there's like 10 of them in a suite, so you can give some to each person in the group and ask, how do you sort it? And then try and write down what that algorithm is. How do you sort? What do you do? Try to write in words. And so if one person wants to be the scribe for the group, then just turn that in. And then you'll be good.
Yeah.